Hello students, let us discuss resonance structures. The phenomena of resonance was put forward by Heisenberg to explain the properties of certain molecules. It is often observed that a single Lewis structure is not enough for the representation of a molecule in agreement with its experimentally determined parameters. So, let us consider a molecule, ozone, in order to explain the resonance in it. In ozone molecule, there are 3 oxygen atom which is bonded by single covalent bond and double covalent bond. The bond length for the single covalent bond is 148 pm and for the double bond is 121 pm. So according to the structure, we expect that 2 bond length in the ozone molecule to be unequal because one of the bond is single, the other one is double bond. But experimentally, it is observed that both the bond length are equal, that is 128 pm, which is and bond length that is intermediate between the single and double bond. This means that this Lewis structure does not account for the observed experimental facts. That means it does not explain all the properties. So to solve the problem, an alternative structures may be drawn. That is like this. In this case, the double bond and the single bond are exchanged. But none of these two structures explain the observed fact. That is, why they have a same bond length, even though there is one single bond and there is one double bond. So it is proposed that the actual structure is in between the two structures. In such a case, we can say that the actual structure is a resonance hybrid. That is hybrid of two structures. That means the actual structure is actually the hybrid of these. Hybrid of this means it is a mixture of these. So the hybrid structure will be like this. So in this experimentally it was found that the bond length for both the single and double bond it is 128 pm. That means both the bond length are equal. So it explains that the actual structure is in between the two structures. So this actual structure is called as a resonance hybrid. So the above two structures, which is called as resonating structures and which is represented by double-headed arrows. The two resonating structures can be represented by double-headed arrows, and the resonance hybrid structures is actually this structure is the hybrid structure of first and second structure. So we can say that according to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, a number of structures with similar energy, position of nuclei, bonding and non-bonding pairs of electrons are taken as a canonical structures of the hybrid which describe a molecule accurately. So in simple words, what we can say that a single Lewis structure cannot explain a molecule accurately. So a number of structures are drawn. These structures are called as resonating structures. And the actual structure is a hybrid of these resonating structures. So the hybrid structure describe the molecule accurately. The resonating structures is represented by double-headed arrows. That means in between the resonating structures, we need to keep double-headed arrows. What it mean by double-headed? Arrow with two head. So this is a representation which is given in between the resonating structures. Now when you look at here, these are the two resonating structure. In this, here there is single bond, here there is single bond, here there is double bond. But what is the other structure? Look at the other structure. Here is the double and here is the single. Nothing but we have exchanged the double and single bond. So how easily we make the structure for that is a resonating structure? Just you need to exchange the double and single bond on the two sides. And the resonating structures, their mixture is called as hybrid structure. So this is the hybrid structure. Hybrids mean the mixture of the two resonating structure is the hybrid structure. In the hybrid structure, here you can see single and double bond. It is not represented fully. It is represented in dotted lines and here also dotted line. It means that the double bond can be here or can be here. So when you observe this one, the bond length is now equal. That is 128 pm, which is the intermediate of the two bond length. That is 148 pm and 121 pm. The intermediate of this is the bond length 128 pm. So this is actually experimentally determined value that it has 128 pm bond length and both the bond length is same. So that lead to the concept of a resonance. So what is resonating structure? According to this concept, the single Lewis structure cannot describe a molecule accurately. Therefore, number of structures are to be drawn. These structures are called as resonating structure and the hybrid of this is called as hybrid structure. Let us make the resonating structure for carbonate ion. In order to make resonating structure, first you need to make its Lewis structure. So this is the Lewis structure for carbonate ion, which we have already discussed. Now how to make the resonating structure for this one? Here in this structure, there is one double bond and there are two single bond. So what you need to make here, just change the position of double and single bond. So here, three possibilities you will be getting. First, let me change the position of double bond in such a way that we will be getting this structure. Now you can check here in this, the double bond, here it is made and in this case the double bond is on this side. But you need to keep that the dots should be made correctly because when there is a single bond, so the dots you can see surrounding to the oxygen. So and for the case of double bond, the dots should be proper. So but when you are changing the double bond, the dots also correctly you have to represent. That is also important. Now again one more possibility is there. That is, in first case double bond is here. Now we have shifted to this side. Now one more possibility that is on this side. So that is like this. And between the resonating structures, these are the resonating structures and in between the resonating structures, we need to keep the double-headed arrows which represent these are the resonating structures. Now, in similar way, when we make the resonating structure for nitrate ion, here also there is one double bond and two single bond. So, three possibilities are there. Therefore, there are three resonating structures. Here also, just change the position of double bond. As you can see here, here is the double bond. Now, in this second structure, here is the double bond and in the third structure, here is the double bond. So that means just need to change the position of double bond and don't forget to keep the charge, that is the overall charge, in the brackets above it. So that is the resonating structure for nitrate ion. In the textbook, resonating structure of a carbonate ion is given. Here, instead of overall negative charges, the charges are given to the particle oxygen atom. So this is also the correct way of representing the resonating structures. Even the resonating structure of carbon dioxide is given. Here also you can see the position. Here the electron are changing. So the electron positions are changing and you will be getting the resonating structures are like this. The most important example for the resonating structure is benzene. In benzene, there are 6 number of carbon atom which are in the cyclic form, and there is an alternate single and double bond. Look at here, there is double, single, double, single, double, single. So there is one possibility of a structure, that is change the position of double bond. When you change the position of this double bond to this side, so this double bond will shift on this side, this double bond on this side. So you will be getting this structure, that is the resonating structures. So the first two structures are called as resonating structures. How we have made this one? Just by changing the position of a double and single bond. And the hybrid of this is this structure, that is represented, instead of double bond, we will be representing a circle in the center. It shows the hybrid structure of these two. In general, it may be stated that resonance stabilizes the molecule as the energy of the resonance hybrid is less than the energy of any single canonical structure. So what we can say that resonance stabilizes the molecule. Why? Because the energy of the resonance hybrid is less than the energy of any of the resonating structures. Resonance averages the bond characteristics as a whole. So this is all about the resonance. So the more detail about resonance will be discussing in the chapter organic. In that we'll be discussing the further examples of resonance. So this is all about resonance. Have a nice day.